Question on energy stored in a capacitor. A capacitor, a parallel plate capacitor of capacitance 20 picofarad is charged to a potential difference of 10 volts. First part is what is the potential energy stored in the capacitor. In the second part, after charging, the power supply is disconnected and a glass slab of dielectric constant 5 is inserted between the plates. Now what is the energy stored in the capacitor? In the third part, the power supply remains connected. After charging the capacitor, we keep the power supply connected. And now we insert the same glass slab of dielectric constant K equal to 5. Now what will be the energy stored in the capacitor in this case? So let's look at the first part. We know the capacitance, we know the potential difference between the plates of the capacitor. So the energy stored is given by half CV square. C is 20 and V is 10. So we get this as 1000 picojoules. Now, in the B part, the power supply is disconnected. Once we remove the power supply, charge is trapped. So Q remains constant. So charge will remain constant because charge is trapped. Once charge remains constant, the potential energy in terms of Q is Q square by 2C. Q is constant. Therefore, this potential energy is inversely proportional to capacitance. And when you introduce this dielectric slab, that glass slab, having dielectric constant 5, capacitance becomes 5 times. Therefore, the energy stored becomes 5 times less because now this potential energy is inversely proportional to capacitance. Don't look at this formula because V is not remaining constant. So we cannot use that formula. Q is remaining constant. Therefore, the energy stored is inversely proportional to C. C is becoming 5 times. So the energy stored will become 1 by 5 times. So the correct answer is 200 picojoules. In the C part, the battery remains connected. If the battery remains connected, V will be constant. The job of a battery is to maintain a constant potential difference across its terminals. So as long as the battery is connected, V will remain constant. And if V remains constant, then the potential energy will be given by half CV square. V is constant. C is becoming 5 times because we are inserting this dielectric of dielectric constant K equal to 5. So therefore C becomes 5 times. And therefore the energy stored will become 5 times, 5000 picojoules. So when the battery remains connected, V is constant. The energy stored is directly proportional to capacitance. When the battery is disconnected, Q remains constant and the energy stored is inversely proportional to capacitance.